Okay, so 5 bases other than E in their application. So we're going to be working with, we've had base E, so we did natural log and exponential, but all base E. We also know that there are others out there, so we need to learn to deal with those. So review with some properties that, well, the definition of a logarithmic function base A. If A is a positive real number, A cannot equal 1, and X is a positive real numbers, then the logarithmic function base A is denoted as log base A of X. Is defined as log base A of X equals 1 over the natural log of A, natural log of X. Okay, that is a horrible way to write the change of base formula. So I'm going to cross this out and just write the natural log of X over the natural log of A. Now we also know that we can do log of X over log of A, correct? What base is the second one? 10. But do we already know how to deal with natural log? Yes? Yeah. So that would make sense to use that. Below are only the rules that you guys already know and been using. So I don't know if I would spend time. They're just a reminder. So if I have y equals a to the x, that's the same as saying x equals the log base a of y. Just changing back and forth. Logarithmic, exponential, logarithmic. I decided that problem the other day, they were wrong with their answer, or if you could somehow simplify, I was going to spend some more time with it and I didn't. But this is the property, the inverse property that we were using. That a to the log base a of x equals x. When we had, what was it, e to the natural log of like x minus 2 or something like that. That equals what? X minus 2. Because your basis of natural log is an e and your base is an e. So as long as these two bases equal, we're right there. And that goes the same as if I have log base a of a to the x, the answer is x. So again, all rules that we've already used, but I just wanted to remind you they were there. Down below are just the expansion rules, the product, the power, and the quotient. Also, log base a of 1 is what?
Log base a of 1
is 0, because anything to the 0 power is 1. Okay, but like I said, below are just those, the the product, the power, and the quotient rule. So when I multiply logarithmics, I'm doing what?
You're
adding. When I'm take a power, the power goes out front. When I'm dividing, I'm subtracting. The only difference from this and what we did the last 2 weeks is it's not natural log. It's not base E. You guys let me know when you're good. Okay. Okay, so solve for x in each. So 3 to the x equals 1 over 81. So we want to use those change of base, not the change of base. We want to, well, we can do it 2 ways. We can throw in a natural log both sides, or we could get the same base. Can we get 81 to be base 3?
Yeah.
Yes. So if we could get it to be 81 base 3, wouldn't it be makes more sense to do like the 1-to-1 property, make it easier on ourselves? Okay, so I have 3 to the x equals 3 to the what? Negative 4. Negative because we brought it out of the denominator, so x equals negative 4. Now, could we have gone log base 3 of 3 to the x equals log base 3 of 1 over 81? You could. And you still get x, and you still have log base 3 of 3 to the negative 4th, which is just what? Negative 4. So we can make these harder using those rules or easier making those rules. I'm going to tell you on the book, this is what they do. I don't understand why you would do it. If you can make them, if I have to do that, like if I have to do that, would I do it? Yeah. But do I have to do that? No. So log base 2 of x equals negative 4. What do you guys want to do? Kind of stuck because of that x is in the domain, right? So how can I get it out of the domain? What allows me to take something out of the domain?
The inverse.
The inverse. So what's the inverse of logarithmic? Exponential. So my base is 2 to the
Negative 4.
equals,
X.
so x equals 1/16. Now, on this one, did we need to change the form?
Yeah.
Yes, but on this one, did we need to? Okay, now I'm going to show you how they did this one. Okay, so we just changed it. We used the inverse property. They took and said 2 to the log base 2 of x equals 2 to the negative 4th. So the left just equals x, correct? And the right is 1/16. Okay, we got the same answer in about the same steps. But this to me sounds like if I had to, like if 4 wasn't like, it wasn't easy to do, that works, right? But this is easy to do. I don't have to do that. So you choose, I guess. Okay, so derivative. So let be a be a positive real number. It can't be 1. Because if it's 1, you don't have an exponential function, correct? Like, let u be a differentiable function x. So again, 1 is an exact form, 2 is a general that you can use on anything. Like a specific, not an exact. So if I have the derivative of a to the x, then that's natural log of a times a to the x. Now, if I want to just use my generalized form, which I probably would, just because. You have d dx of a to the u is the natural log of a times a to the u and du over dx, which is the same as the derivative of u. So I would write this as the well, I wouldn't put it in that order. Anybody else not like that order?
Yeah, I wouldn't.
A to the u prime, natural log of a. Now, I might like that order depending on what u prime is, right? But I don't like the order when I write it. So that is the exponential rule when our base is other than e. Can I just go to 4 since it's the general, or do you guys want the specific too? I'll go through it. Okay, so the derivative of the log base a of x is 1 over the natural log of a times x. Okay, so the derivative of log base a of u is 1 over the natural log of a times u times du dx. Now, I'm going to write this like we would. How did we do with logarithmics before? We put u prime over u, correct? So let's make it similar to what we know. Shouldn't we do that? So it's going to be u prime. Where did the u prime come from?
The u prime came from
Du dx, right? Over u, the natural log of a. So the only thing we added was what? That natural log of a.
Yeah.
And is that the only thing that we added to the exponential rule? Yes. Because it was e to the u prime for exponential, right? You're adding that natural log in there. That is that change of base, guys. That's where that change of base comes into play. So y equals 2x. I need to find the derivative. So u is what?
X.
X. So u prime would be
2 or 1.
1. So my y prime would be 2 to the x, so 2u. So 2 to the x, not 2u. It would be 2 to the u, so it's 2 to the x. I cannot talk. And then times the derivative, which would be what?
The derivative is
1. Do you want me to put the 1 in there? I'll do it just for this. And then the natural log of a, which is what? 2. So y prime equals 2 to the x, the natural log of 2. I guess I didn't identify a, but a is always the base, right? Not a whole lot different than what we've been doing. Okay, so y equals 2 to the 3x. So u is,
3x.
and u prime is, looks like a mu. U prime is 3. So y prime equals a to the u, so 2 to the 3x, times u prime, which is 3, the natural log of 2. So I about multiplied 2 times. Oh, that would have been horrible. I do not like how that looks. So I'd put 2 to the 3x. Natural log of 2. But honestly, did I change it any? No. I just got that constant out in the front like we're used to seeing. So it can be a coefficient. I about said a 6 to the 3x. You guys would have to make fun of me if I did that. Okay, so this one we're using 4, right?
4. Oh, yeah. They just digit 4.
Oh, yeah. Because we're a logarithm. Okay, so u is cosine of x. U prime is negative sine of x. On this one, I am going to ask you what a is.
A log. Oh, yeah.
It's 10. Okay, I ask you that because there's nothing there, right? It's the common log. So we remember that. Okay, so that we're going to use this right here. We're not going to go through all that garbage. So y prime equals u prime negative sine of x over u. Look how I wrote cosine of x, and you guys did not. Oh my god! I just.
Yeah, she wrote Cox. You did.
Cox cable.
Yep.
Okay, so then I have u times natural log, right? So I don't know which one's better. You want logarithm first or cosine first?
Cosine.
So cosine of x, natural log of 10. I'd probably put the natural log first. Couldn't handle the cosine first. These things bother me because I go back and forth how I want it to look. So basically just finding u prime, right? And plugging it in. Questions? Concerns? Done.